Okay, good morning, everybody. So, today we are going to discuss this first unit of class 12th physics syllabus, electric charges and fields. Then we have the other unit, electric potential and capacitors. And the third unit, third part of this first unit is current electricity. So, here in this first unit, what am I using is Oswald's mind maps, and we are going to do a quick revision of this chapter. So, this chapter, electric charges and fields, starts with electric charges. The electric charge, the fundamental property of matter, due to which the charge experiences a force whenever you keep it in any external electric or magnetic field. So this is how the electric charge comes out as another property different from mass, which is another fundamental property of matter. So electric charges are of two kinds. One is the positive charge, negative charge. The SI unit to measure charge is coulomb. And what is 1 coulomb? 1 coulomb is a charge flowing through a wire in 1 second if a current in it is 1 ampere. So basically, this definition that they have got is through I is equal to Q upon T. So when this is 1 ampere and this is 1 second, which means this Q will be 1 coulomb. So based on that, they derived 1 coulomb of charge. Next is the two properties of the charge. One is the conservation of charge and another is the quantization of charge. What is conservation of charge? That for any system given to you, like atom or any system of charges, we are not able to create or destroy any net charge of the isolated system. We can neither add the charges nor reduce the charges for an isolated system. Isolated means the system is constrained from external factors. The next is the quantization of charge. Quantization means the charge is quantized, means the charge is always found in quantities. It is never found as continuous thing. Charge is always found as a multiple of Q is equal to Ne, where N is an integer and E is the number, which is equal to 1.6 into 10 to the power minus 19 coulomb. So this is the charge of one electron. This is the magnitude I'm talking about. You don't need to go with this fact that any body can have only the negative charge. It can have the positive charge also, but the charge has to be a multiple of 1.6 into 10 to the power minus 19 coulomb. So this is about the charge. Then the second thing that we'll study about charges is Coulomb's law. Coulomb's law is given by this person. You can study about him. He's in 1985, Charles Augustin de Coulomb gave Coulomb's law. So this is somewhat given in your NCERT also, but not to be asked in your physics exam. So what is Coulomb's law? It says that whenever you keep two charges close to each other, the charges must be having the magnitude q1 and q2, and they are kept at a distance r from each other. Means if you have a system like this and you have two charges, one is q1, another is this q2, they are kept at a distance r1. This is the first position vector for this first charge. R2 is the other position vector, r1 and r2. They are kept at two different positions. The distances between them can be given as r2 1, position vector of 2 with respect to 1. So this is what I made. So when two charges are kept in this way, the force between the charges along with direction is given as k q1 q2 by r cube, and here r vector is also further added. Now this r upon r gives me r cap, that is the unit vector along the force. So if q1 and q2 are of the same magnitude, or you can say q1 and q2 are of the same nature, then they both would repel each other. So you can see the force on 1 due to 2 would be in this direction, repulsion, and force on 2 due to 1 would be in this direction. So this is how it will happen. So they are equal and opposite in nature. The action reaction pair thing is working here, that if one body is applying force on another, the another body is also applying the equal force on the first object, and they both are in the opposite direction. So force is attractive when q1 and q2 are of opposite sign, whereas otherwise it is repulsive. So this is the magnitude of the force that we keep. And when you apply, like when you would be solving it, you would have to apply the parallelogram law, vector addition, or the components that you have always studied. Like whenever you see a vector, divide that. For example, if you find that force is along this direction, you can have f cos theta in the x-axis and f sine theta in the y-axis. And same you can do for other pair of charges, and this way you can get the net force on any system. Here k is equal to 1 upon 4 pi epsilon naught, where epsilon naught is your permittivity, electric permittivity of free space. Epsilon naught, when they have mentioned epsilon naught, this dot naught sign is saying that it is for free space. It is not for any other medium. It's for vacuum or air, you can say. So the magnitude comes out to be 9 × 10 to the power 9 Newton meter square per coulomb square. You will put this value here and you can get the answers. Whenever you solve such questions, you can do a little rounding off also, because that would make the calculation easier and would allow you to get it done. Now force between multiple charges, if this is given to you, like for a system which has many forces, which has many charges, then in that case you have to calculate the force on any charge. So this is your first charge, this second charge, third charge, fourth charge, fifth charge, sixth charge. In that case you will be applying your parallelogram law of vector addition, or we call this as superposition principle, where you will be finding the forces acting on 1 due to 2. For example, if 1 is positive, 2 is negative, the force would be in this direction. Similarly, for oppositely charged natures, this would be the direction of forces. This is when am I making them? When they are oppositely charged. So there is attraction, you can see. Similarly, you can see another force. Now if I have to put present this system of forces, I would write it as force on 1 is equal to force on 1 due to 2 plus force on 1 due to 3 plus force on 1 due to 4 plus force on 1 due to 5. Everything has a vectorial sign. This indicates that you have to add them vectorially. You can't directly algebraically add them. Numbers नहीं है ये कि 5 4 3 2 1 को आपने ऐड कर दिया. आपको देखना पड़ेगा कि कौन सा फोर्स किस डायरेक्शन में है. फिर इन सभी फोर्सेस को यू कैन ऑल्सो डिवाइड इट अलॉन्ग एक्स एक्सिस एंड वाई एक्सिस. लाइक यू कैन गेट द कॉम्पोनेंट्स ऑफ ईच ऑफ दिस फोर्स. F12 को आप F12 cos थीटा प्लस F12 sin थीटा जे के आप लिख सकते हैं. यानी एक कंपोनेंट आपने एक्स एक्सिस का लिखा, एक कंपोनेंट आपने वाई एक्सिस का लिखा, एंड दिस वे यू कैन गेट योर फोर्सेस एंड ऐड ऑल द फोर्सेस अलोंग द एक्स एक्सिस. यानी एक्स के जितने भी कंपोनेंट है F1x प्लस F2x प्लस जितने भी फोर्सेस एक्स के अलोंग हैं उन सबको आप ऐड करके अपना एक्स का डायरेक्शन लिख सकते हैं. एंड देन सेम यू कैन डू फॉर वाई एक्सिस cases. And this is how we do the vectorial addition. The generalized expression they have written for this. Again आपको पता है force है Q1 और QI के बीच में. I is another charge. Then 4 pi epsilon naught is given to you. Then R1I is also here. And direction is given. So basically this is a generalized expression for all these forces. Now here unit vector, it's mentioned to you, unit vector has magnitude of 1 and it has a direction. It indicates the direction only. So whenever you have to have a unit vector, you will mention it as R upon the magnitude of this R. This gives you a unit vector. So the electric force with which two charges attract or repel one another are not affected by the presence of other charges. It is known as superposition principle. Superposition principle क्या कहता है कि जब भी आपके पास कोई सिस्टम है चार्जेस का और उनके बीच का फोर्स आपको निकालना है, तो दो चार्जेस के बीच में लगने वाला फोर्स किसी तीसरे चार्ज के फोर्स की वजह से अफेक्ट नहीं होता. यानी अगर आपका पहला चार्ज है Q1, देन अनदर इज Q2, देन अनदर इज Q3 एंड यू हैव टू फाइंड द फोर्स ऑन Q1. सो आपको कुछ नहीं करना है. आपको Q1 पर Q2 की वजह से फोर्स ऑन 1 ड्यू टू 2 एंड सिमिलरली 1 पर 3 की वजह से, यानी कि फोर्स ऑन 1 ड्यू टू 3. ये दोनों चीज़ें आपको निकालनी पड़ेंगी. एंड देन दिस वे यू कैन गेट द फोर्स ऑन 1 एज फोर्स ऑन 1 ड्यू टू 2 प्लस फोर्स ऑन 1 ड्यू टू 3. सो बेसिकली 2 की प्रेजेंस की वजह से 1 पर जो 3 की वजह से फोर्स लग रहा है उस पर फ़र्क नहीं पड़ा है. तो जो भी फोर्स है वो एड अप हो रहे हैं वेक्टोरियली. दिस इज योर सुपरपोजिशन प्रिंसिपल. इसमें इस बात का ध्यान रखिए कि जो चार्जेस के बीच का आप फोर्स निकाल रहे हैं उनका नेचर सेम नेचर का है या अपोजिट नेचर का है. अगर वो सेम नेचर का होगा तो उनके बीच के फोर्सेस रिपल्सिव होंगे, यानी फोर्स की डायरेक्शन जो मैंने इस केस में बनाई है वो इसके अपोजिटली आएगी. फॉर एग्जांपल इस केस में मैंने बनाया है कि फोर्स ऑन Q1 ड्यू टू 2 वुड बी अलोंग दिस डायरेक्शन. सो ये मैंने कब बनाया, जब 1 और 2 अपोजिट नेचर के हैं तभी वो अट्रैक्ट कर रहे हैं. अगर ये दोनों अलग नेचर के होते तो इस केस में क्या होता कि 1 2 3 Q1 2 की वजह से रिपेल करता और सिमिलरली Q1 भी 3 की वजह से भी रिपेल करता. तो इस तरीके से आपके पास 1 2 F1 3 ये दो फोर्सेस आते हैं और दोनों अपोजिट डायरेक्शन में आते हैं. So this is how the things matter, and this is how the basic questions of Coulomb's law have to be done. And it's not about just the questions on Coulomb's law, it's also about electric field, about which you are going to study in a while. Okay, so ये बहुत बेसिक है. फिजिक्स के न्यूमेरिकल करने के लिए आपको डायरेक्शंस पहले डिफाइन करनी पड़ेंगी, दिखानी पड़ेंगी, एंड देन आप इस पे वेक्टोरियल या रेजोल्यूशन, वेक्टर रेजोल्यूशन लगाएंगे, एंड दैट्स हाउ यू विल गेट द आंसर्स. सो दिस इज हाउ इट इज़ विद कूलम्स लॉ एंड सुपरपोजिशन प्रिंसिपल. अब इसके बाद हम आएंगे इलेक्ट्रिक फ्लक्स के ऊपर. Before we come to electric flux, let's talk about electric field. So what is electric field? Electric field is basically the property of a region. अक्सर बच्चे कहते हैं कि electric field is the region where charges experience force. तो ये जगह नहीं है. फील्ड एक्चुअल में एक फिजिकल क्वांटिटी है. इसका कुछ मैग्नीट्यूड भी होता है, इसकी डायरेक्शन भी होती है. तो जब मैं फील्ड कहती हूँ तो इट्स अ फिजिकल क्वांटिटी एसोसिएटेड विद स्पेस. यानी आपके पास कोई जगह है और उस जगह पर हर पॉइंट पर इलेक्ट्रिक फील्ड डिफाइंड है. यानी कि हर पॉइंट पर अगर किसी चार्ज पार्टिकल को रखा जाता है तो वो चार्ज एक फोर्स एक्सपीरियंस करता है जिसकी एक पर्टिकुलर डायरेक्शन है, एक पर्टिकुलर मैग्नीट्यूड है. दिस फिजिकल प्रॉपर्टी ऑफ स्पेस इज कॉल्ड एज इलेक्ट्रिक फील्ड. So field is the property of space. It is not a region. Never define electric field as electric field is a region where charge experiences force. No, electric field is the property of a region where any charge, if kept in that region, would experience a force. Now, if I have to find the electric field due to a point charge, means कोई point charge आपको दिया है, उसके पे लगने वाला आपको force आपको ये वाली बात आइडेंटिफाई करनी है कि उस चार्ज के आसपास हम कोई पॉइंट रखेंगे. फॉर एग्जांपल दिस इज योर क्यू चार्ज एंड आई हैव टू फाइंड दैट फॉर एनी पर्टिकुलर पॉइंट विच इज एट अ डिस्टेंस ऑफ r फ्रॉम दिस चार्ज. आई कॉल दिस एज p. what would be the force? So E is equal to F upon Q. Force per unit charge means if I have placed a charge Q here, and the force between the two charges would be KQQ by R square, right? Now the point is I need to find the force per unit charge, small per unit charge. So I'll divide it with Q and this gives me this KQ by R square, you can see. So the quantity that I'm getting is Newton per Coulomb. This was force, force is in Newton and then Q is in Coulomb. So this is how I solve it. The unit for this is Newton per Coulomb. Then for discrete distribution of charges, for example, if you have a particular system of charges which has many charges, the electric field at any point would be given as a vectorial sum. Vectorial sum. So you can see this is a vector quantity. So you have to add these vectorially. So for any point, the electric field would come out to be the sum of electric field due to different charges. For example, this would become E1 plus E2 plus E dash dash En. For n system, n charges, this electric field at any particular point would be given as a vectorial sum of electric field due to all the different charges. Now what is due to continuous distribution of charges? Electric field can be given as K. Now this is continuous distribution charge, means you don't know what charge is placed where. It's just a region where charges are distributed continuously. For example, you can have a spherical surface over which the charge is uniformly distributed. Now in that case, you cannot have any particular point having any fixed charge. So in that case, you define an infinite, similarly small region which you define the charge as dq. यानी आपने एक बहुत छोटा सा स्मॉल रीजन लिया जहाँ पे आपने चार्ज को क्या कहा है कि वो dq है. तो अब इस चार्ज पे लगने वाला, इस चार्ज की वजह से जो इलेक्ट्रिक फील्ड जनरेट होगी, इट वुड बी k dq बाय r क्यूब, और ये r वेक्टर आप देख रहे हैं. इसको मैं फर्दर ऐसे भी लिख सकती हूँ k dq बाय r स्क्वायर, बट मुझे यहाँ पे r कैप लिखना पड़ेगा. इसका ध्यान रखिए. r क्यूब तब आता है जब ऊपर के वेक्टर को भी r के मैग्नीट्यूड से मल्टीप्लाई करते हैं. So once this is done, you get k integral dq by r square. इंटीग्रेशन हमें तब करना पड़ता है जब भी कंटिन्यूस सिस्टम होता है. अब इसके बाद मैंने इस रीजन के लिए, अगर इस पॉइंट, इस इनफाइनाइट सिमिली स्मॉल रीजन के लिए एक इलेक्ट्रिक फील्ड डिफाइन की है, तो वंस आई इंटीग्रेट इट ओवर द होल सरफेस, आई गेट द इलेक्ट्रिक फील्ड ड्यू टू दिस होल spherical distribution of charge. So this is the generalized expression. This we must know. Next is, what are electric field lines? So electric field was a physical quantity associated with system which tells me how much force would be acting on a charge which is kept at any position in the electric field, and what would be the direction of that force. This was the electric field. Now what are electric field lines? So electric field lines are a method through which we can further understand the electric field. For example, electric field is a property which is continuous, which is described over a region continuously. Means a space is given to you and at each point you have electric field defined. But the point is, it's very difficult for a human mind to understand the continuous quantity, how it's varying and everything. So electric field lines are a discrete representation of electric field. To represent these electric field lines as a form of lines, electric field in the form of lines, we define electric field lines which always originate from positive charge. So electric field lines always originate from positive charge, and they always orient towards the negative charge. They always move towards the negative charge. So when it's about the conducting surfaces, for example, a conducting surface is given to you, and then you have charge over that surface. So for this conducting surface, if you will draw the electric field lines, you'll find them that electric field lines are always normal to the conducting surface. They could have moved in random directions, like some have gone this way, some would have gone this way, but you would find that eventually that all the electric field lines which are going in the upward direction, there would always be symmetrically defined electric field lines in the downward direction. As a result, net electric field in the vertical direction would come out to be 0, and only thing that would be left with you will be the electric field along the horizontal direction. So this is how you have to keep this in mind. You have to have this habit of resolving the vectors and getting the things done. So then lines originating from positive charge, you can see, terminating at negative charge, you can see further that they always terminate at negative charge. They never intersect each other, because if they would be intersecting each other, this would mean that electric field lines are in two directions. At any point P, you would be finding electric field orienting in two directions, which is not possible. That's why we have electric field always all electric field lines never intersecting each other. Then they do not form closed loops. Unlike the magnetic field lines, they never form closed loops, and they're imaginary lines. Okay, it's not like electric field lines are originally there. They're a method to understand the electric field as a continuous property, but then electric field lines as a discrete property. Next is, once you have studied about electric field lines, the other concept that we need to study is electric flux. Very important concept. They ask you questions regarding defining electric flux, and if you don't know the definition, at times the formula comes in your rescue. For example, the electric flux is given as delta phi. Phi is given, so I have written delta phi here to ensure that, just a second. Yeah, I believe the screen is not showing you.